Alright guys, sorry it took me so long to upload this. With logs, technically there's not a parent function, so we're going to treat whatever base it has as the parent. Meaning, if I have something that's like
as beautiful as I imagine.
then I'm going to assume that the parent function is log base 2 of x. I think on the handout I did on the Thursday side, it's going to have a different base each time. The base doesn't matter for the parent function. So if I have this, that's the same thing as if I have, it doesn't matter what the base is, okay? Whatever the base is on the problem, just assume that the parent function, it looks like one of these, okay? So we're going to have, I'm going to use log base 2 on all my examples. We're going to have our a right here, our b right here,
without a single tie to his own.
oops, our h is part of the of, I should have another parentheses, and our k is not part of the of. So notice that both the b and the h are parts of the of, okay? And the a and the k are not parts of the of. So if I have something that looks like the only thing I have right now is an a of 3. Whenever a has an absolute value larger than 1, it's going to vertically stretch it. So this is going to be vertically stretched by a factor of 3. Okay? It's hard to write because I'm holding my phone with my left hand. I apologize. So, if I get something that tells me over a number, remember that this piece right here is mathematically equivalent to 1/4 times the log base 2 of x. So that means that my a value on this one and this one, they're mathematically equivalent. So that means that the a value here and the a value here are both 1/4, which is going to be a vertical compression by a factor of 1/4. So whenever it's over a number, that's the same thing as being multiplied by a fraction. So if it's being multiplied by a fraction, that's an absolute value less than 1. So that's a vertical compression. Now the b values are going to be part of the of. So if I have something that's like this, remember that I need to factor it away from the x. So that means it's going to become log base 2 of 2 times x plus, this gets divided by 2 and this gets divided by 2. So 2 plus 1/2. So that means I have a b value of the multiplicative inverse of this. So that's a b of 1/2, which is an absolute value less than 1. So that's going to be horizontally compressed by a factor of 1/2. This is going to move it to the left 1/2. Anytime you have something inside of there that's a b, you need to factor it away from the x. So if I have 4x minus, let's make it 8. I'm going to make this x minus 2. So it's going to have a b value of 1/4, which is going to be horizontally compressed by a factor of 1/4. And this is going to move it to the right too. So we need to remember that with b's, they have to be factored away from the x, and that also happens to the value that's right here. Okay, every single time. Anything that's negative also needs to be factored away. And that's where I say a lot of you guys make the mistake. So on this one, it's going to become -2 times x plus 9. Because when I divide -18 by -2, it gives me +9. So that means I really have a b value of -1/2, which the negative is going to reflect it across the y-axis. The 1/2 is going to horizontally compress it by a factor of 1/2. And the 9 is going to move it to the left 9. Okay, 2 more examples.
Legend say it has been known to mend souls and heal broken hearts.
Legends which are totally unsupported by fact, Captain.
Legends like that are the spice of the universe, Mr. Data, because they have a way of sometimes coming true.
Okay, so a is -4, which is going to reflect it across the x-axis because it's negative. It's going to vertically stretch it by a factor of 4 because it has an absolute value larger than 1. This is going to reflect it across the y-axis because it's a negative here. And it's going to horizontally compress it by a factor of 1/3 because it's an inverse of this number. This is going to get divided by -3, so I'm actually going to move it to the right 4/3.
Yes, sir. There's an object of some kind beaming in from Haven.
Last example.
We're not sure.
The surface station approval coming in now, Tom.
All right. Let's bring it in.
Now remember, an exponent comes down to the front of the log, so this is really my a value. So this is the same thing as 7 times the log base 2 of x minus 3. So that means that this is going to vertically stretch it by a factor of 7. This is going to move it to the right 3. Hopefully that all makes sense. I want to put this up there one more time just so that we see it again. Don't forget that a can be written here on a log, and it also can be written up here on a log.
What's going on?
Now, kind of ran out of paper, but with exponentials, it's the same thing. It doesn't have technically a base, so whatever the base is, if it's a 2, then that doesn't do anything, okay? That still isn't going to do anything. We're going to assume that this is the parent function if we see a problem that looks like this. We're going to assume that this is the parent function if we see a problem that looks like this. I'm going to use 2 on my example. It's going to be a times 1 over b x minus h plus k. So the b and the h are in the exponent. The a and the k are not they're not part of the exponent. Okay? Now every once in a while I'll do one just to mess with you that says use log base 2. A base of 2 on the exponential. If I have one like that and it actually says 4 right here, that's me trying to trick you, okay? If I have something like this, okay, I need to turn this into a 2. So that means 4 is the same thing as 2 squared. So then I have, these are mathematically equivalent. So that means I have a b value of 1/2. So it's going to be horizontally compressed by a factor of 1/2. This is going to move me to the left 2. And this is going to move me down 9. I don't think I did a lot like that, but I think I did do a couple of like that on Friday as a set. Hopefully that makes sense.